Hello, everybody. My name is Robert Douglas, and this is yet another episode of Deploy Friday, the webcast and podcast hosted by myself and sponsored by Platform.sh. Today's episode is quite interesting and quite fun. It's unlike any that we've done so far. I have three members with me today of the Open Infrastructure Foundation. And we're going to go into what that is, what kind of software they work with, why they exist, how they came to exist, what you can get from them and do with them, how you can interact with them. All of that is going to be included in the show, but we're going to do introductions first. So I would like my guests to introduce themselves one by one, starting with you, Julia.
Hi, I'm Julia Kreger. I'm a principal software engineer at Red Hat. That's my day job. My work with the foundation is I'm a director on the board of directors, and I also help run one of the projects.
And Julia, you're sitting in an RV right now, is that right?
Yes, I am.
So you're enjoying the lockdown by locking yourself into a house on wheels.
I had to get out of my house.
Check that.
Sanity.
All right. Well, thanks for being here. How about you, Mark?
Yeah, so I'm Mark Collier, Sparky Collier on Twitter, and I'm the COO at the Open Infra Foundation, and was one of the folks that, when I was at Rackspace over about 11 years ago, helped get the Openstack project started, and we created a foundation, and it's the Openstack Foundation. Now, as we've grown, we've become the Open Infra Foundation, so I work full-time at the foundation, and these are a couple of my board members, so I have to be on my best behavior, but that's how I fit into the picture. Excited to join today.
Thank you. Excellent. And Mohammed, how about you?
Thanks. So my name is Mohammed. I'm the CEO at VEXXHOST. We're a company that specializes in infrastructure solutions, like we have public cloud and private cloud offerings. In the community, I'm one of the members of the Openstack technical community, as well as one of the individually elected directors on our foundation. I think that's something that will be interesting to talk about as we get to chat about our foundation.
Totally. I'm going to put a pin in the term individually elected, and we'll come back to that to know what that means. So I think that the first thing we should start out with, though, and I'm going to turn to you, Mark, as it seems that you're maybe the senior person involved with the project the longest. What is the Open Infrastructure Foundation? And you already given a little bit of its history. Maybe you can fill that out a little bit and tell everybody on the show what you do and how you came about.
Yeah, so the Open Infrastructure Foundation is a nonprofit, and we're focused on helping build communities that write software that runs in production, specifically for infrastructure. So you think about cloud computing, out to edge computing, so kind of automated infrastructure as a service. We've been through all the buzzwords up and down over the years, but this foundation really is backed by 100,000 members all around the world. We have members in 180 plus countries. So it's a very, very global movement, and the nonprofit is there to really support and nurture the community, organize events, organize, a lot of the development activity. But the developers really are all volunteers in a sense. They're not foundation employees. They're people that work at a lot of other companies like Red Hat, VEXXHOST, and on and on and on. Many, many companies. So what we had, our origins were really because of the Openstack open source project. In fact, just yesterday we had our 23rd on-time release of Openstack. So 11 years in, still one of the 3 most active open source projects in the world. And so about 2 years into starting Openstack, we realized it was just Rackspace and NASA and some others working on it to make it bigger, more inclusive, accelerate the adoption and the community building. We created a nonprofit foundation, the Openstack Foundation. And then at the beginning of this year, we became the Open Infrastructure Foundation because the things we learned with Openstack, we want to apply even bigger, make a bigger impact. So Openstack is a part of one of the projects we support. It's the biggest, but we now have 7 different projects that we're working on or helping the community work on. So that's kind of a little bit of background, but as a nonprofit, we bring together all the different stakeholders and just try to help everybody work together collaboratively all around the world, very, very global. And so it's an awesome job. I'm lucky to have it.
Fantastic. So Julia, what's your purview within the foundation?
So my purview is I'm both a contributor and like Mohammed, I'm an individually elected director. So I can jump into that. Or
yes, please. Now we've heard it twice, and before the confusion becomes rampant, I need to know, what does that mean?
So when you look at nonprofits, they can be structured any number of different ways. In our case, the Open Infrastructure Foundation is a 501c6 nonprofit, which in U.S. tax code is basically a industry. I can't think of the word. It's like an industry group, basically, and that's largely because IRS, Internal Revenue Service, doesn't really like or trust the idea that you can have open source and nonprofits built around them.
I know, it's very suspicious.
Yes, it is. So as an industry association, basically you have member companies, and then you have member bodies, and you have member companies, member bodies, and you can basically have your bylaws however you want. In this case, in the Open Infrastructure Foundation, or previously Openstack Foundation, the way that was arranged was corporate sponsors had a seat. A second class of members, called, I believe, gold members, or now platinum, could elect 8 members or to the board. And then the actual community members, like the individual contributors, could elect members to the board. And so we hold elections yearly, and I was selected by the member body to represent the member body, and that's my role in the foundation. And is
it safe to presume that that means you've been a very active contributor to the software, and the doocracy rewarded you by you being at the center of a lot of conversations and building trust, and that's how you got your votes?
I guess.
Yes. I'll brag for her. Yes.
I did look at my stats recently. I went, how did I do that much? But it's I've been involved for 7 years now, and I feel very strongly about the mission. I feel very strongly that we are creating value, and that we enable other communities to build even more cool things. It's just there's a level at which people don't want to care, and a lot of the infrastructure is at that level, because it's like thinking of like you're an engineer on a starship. You know your warp drive. You don't really need to know, I don't know, how the console works.
Right. I mean, these are the questions I never ask when watching Starship scenes, right? Like, how does that work? No. Just roll with it. It's all good. OpenStack's got it covered. Good. Mohammed, what's your purview?
Well, so I've been involved in the OpenStack Foundation initially, but now Open Infra Foundation for like roughly 9 years, or maybe it's my 10th year now. So I've kind of seen it grow and do a lot of progress. And throughout that, I've been lucky enough, thanks to all the many amazing contributors that actually help and kind of give a lot of guidance and push towards, hey, you should try this, you should give a shot to that. And so I kind of started as just an individual contributor at the project. And then with time, I got more involved in more of the deployment tooling. And then with more time, because we are a deployer, and as well as me being involved upstream in the deployment tooling, I was encouraged by some community members and said, hey, why don't you try joining the technical committee? So to take a small aside, is the way the governance overall works is you have the OpenStack, or the Open Infra Foundation, that kind of, that governs, has the copyrights and a bunch of stuff like that, legal stuff, let's say. And every project has its own governance. So the Open Infra Foundation doesn't tell you how to run your project. It kind of stays there and helps out and makes sure everything is flowing properly, but it's up to the individual projects to decide on how they want to do their governance. And so in my involvement, at least in the OpenStack, we have something called the OpenStack Technical Committee, which the OpenStack project is governed by. And so I got involved in that, and then with time, eventually kind of became the chair of the technical committee, and then eventually decided that maybe it was time to see what the OpenStack kind of be more on the Open Infra Foundation. Sorry, I keep saying OpenStack because we've been saying it for like 8 years now. It's kind of hard to break the habit. But
muscle memory.
Yeah, but so that's kind of the main thing, right? So there's all these other projects that have their other kind of way of setting governance. And the Open Infrastructure Foundation is kind of at the top. And I am, while I have my own company and we deal with that, but to me, when I'm sitting on the board seat, it's purely in the interests of our contributors, and that's always how it's been. And in my opinion, being somebody who is running a company, usually the best interest of the community will very well and most likely line up with the best interest of commercial interest, like 100% of the time, probably. So it's a great, group of people to be working with.
Great. So the Open Infrastructure Foundation came from the OpenStack Foundation and is thus very OpenStack centric, even though you've brought in other projects. So I would like to hear, I'm going to go with Julia again. We'll get to you, Mark. Can you give us an idea of the breadth and scope of OpenStack just in general? Because not everybody is really familiar with that software.
Okay, so it's kind of hard to put into words, but if you think about all the individual things you need to create everything in software and to orchestrate everything in software, you need lots of lower level pieces, lots of small engines here and there that drive bigger engines that help move things forward. So OpenStack at its very core started with a few key projects, mainly focused around block storage, virtualization, object storage, networking, these sorts of key things, and has since grown. So now there are OpenStack projects to install OpenStack. There are OpenStack projects to help manage the bare metal, which happens to be the project I lead. There was a project that was an OpenStack that helped us run our CI/CD platform, because it turns out that we were really good at destroying CI/CD systems because we have a model of never merging broken code. So we have just this whole slew of projects that we've had to build and orchestrate and integrate, and basically allows you to use software to manage your infrastructure as if you're using a cloud provider, because you're making your own cloud.
So the short answer is you got a bunch of computers in your closet and you want to be AWS on your own, OpenStack. That's a pretty good summary.
Yeah.
All right, got it. Now I know what to do with those things. I've just been mining Dogecoin until now. I'm just like, what's that good for?
By the way, more today than yesterday.
Yeah, exactly.
Right. When you said platinum sponsors, I was just wondering how long it's going to take before you've got like Bitcoin sponsors, Ethereum sponsors, and Dogecoin sponsors, and like, who wants metal, right? Like, who wants these like bars of silver? I don't want to be a silver sponsor. That's heavy. It's not appreciating fast enough. So, Mark, I've got a question for you, and that is, can you describe then the other software projects that you've taken on? How were they chosen? Were they spun off of OpenStack? Were they inspired by OpenStack? Do they have an affinity to OpenStack? And what does it take to get into the Open Infra Foundation as a software project?
Yeah, great question. So
that was seven questions. By the way.
Well, so Julia actually alluded to one of these projects that came out of our efforts to build OpenStack, and just to kind of drop a couple of stats to put it in perspective. Like, OpenStack, since its inception, has over 8,500 developers that have contributed to it. We would do releases every 6 months. We just had the 23rd release yesterday. So, in a typical cycle like that, we get 17,000 changes merged in just 6 months from developers all over the world. So when you think about like having to take that much code from all over the world every single day, thousands of developers over the course of the project. It broke a lot of the existing tools out there. I mean, it didn't, a lot of the stuff that we took off the shelf, to open source or whatever, it didn't quite scale or meet, the needs of a community that distributed. And so one of the tools we built was called Zool. By we, I mean, the community at large, the OpenStack community. So Zool is a CI/CD system. Their slogan is stop merging broken code. And as development of software in general has just picked up the pace and people are constantly trying to ship code faster, get it into production, whether it's for SaaS or whatever delivery you're trying to do to actually just get the code in front of customers, it's really easy to, in the old model, kind of write a bunch of code, then test it, put it in QA. Now we're talking about continuous testing. And part of the innovation with Zool is actually it tests the different changes that are being proposed before they even merge into the main branch. So on a daily basis, every single code commit, actually combinations of code commitments, when you have somebody in Germany and somebody in China and somebody in the US and Canada, they're all trying to throw new changes in there. And it says the speculative execution, all kinds of wild stuff to kind of predict, well, what happens if we merge these in this order? Is one thing going to break? So when you think about just the applicability to all kinds of software development, it's massive. And in fact, we have companies like Volvo, BMW, Leboncoin, who's one of the largest e-commerce companies in France. They're adopting Zool for just different use cases. They're not using it because they're using OpenStack. They may or may not be using OpenStack. They're using it because they have a lot of software developers. They want the code quality to go up. They want the speed to go up at the same time. So you want speed and quality, and that's the Zool project. I could probably take up way too much time going through all the projects, but we have Airship and Starlingx, which are both kind of the best of taking components or taking pieces and platforms from OpenStack and Kubernetes. Kubernetes is extremely popular these days, and people run it with OpenStack all the time. And both of those projects kind of help with edge use cases. So Verizon, for example, in the US, I think it's one of the largest mobile carriers in the world. They're using Starlingx in production. And so, that's for their kind of mobile access networks, radio access networks. So this is kind of what we've been doing is taking the OpenStack playbook, the philosophy of being very inclusive, being very global, allowing no matter what country you're in or what company you work for, you can be part of the community. You can help test it. You can write the code. You can write the docs. You can run it. Just taking that what we've learned and opening it up to more people. And that's kind of what we're trying to do as we evolve the foundation, is just take all the amazing tooling and methodologies and sort of philosophies, really. You could call it the OpenStack way if you want. The 4 opens we kind of talked about as well, but we've taken that and started to help other projects. Kata Containers is another one. So I've probably taken up all my airtime, but that's kind of the idea in a nutshell.
So you just mentioned one of the topics I wanted to get to, the 4 freedoms. And we haven't talked about that yet, I don't think, not on the show. And anybody who's been exposed to free software is already, familiar maybe with the concept of the 4 freedoms, but you're talking about a totally different set of 4 freedoms. They're the 4 freedoms of free code, but you're talking about the 4 open freedoms. Mohammed, do you want to take this one and tell us what those are?
Sure. Yeah. So something that started actually again in OpenStack initially, and again, that's kind of the whole idea of the Open Infra Foundation, is taking those and helping other projects leverage those to build communities around them, or successful communities like we did in OpenStack. And so we have 4 opens inside that we came up with. And so the 4 opens is open source, open design, open development, and open community. And so going one by one over these, the first one is open source, which is in OpenStack and kind of hopefully anything that uses the 4 opens. We don't build open core software. We don't do anything where there's a part that's behind some sort of paywall or something that's not available, or features that are not fully exposed to a specific user or anything like that. And so everything has to be 100% open source. There's no faster version that some vendor has. And we don't allow for someone to put in some code so they can go ahead and like add a plugin to make it go faster or something like that. It's really got to work. And in these open source as well, it has to be open source licenses. So there's a couple of different licenses that the projects all have to use so that they can be kind of real open source. We have open design. So some of the things that need to say is when you come up with a bunch of requirements and when we want to figure out and design a feature, the design part of it needs to happen in public. So, if you're trying to come up with, Julia's here, so I'm thinking bare metal, right? Like, bare metal recently added a whole bunch of features about using, RAID, and so that it can boot machines with RAID pre-installed. And let's say you wanted to add support for RAID 5 or something else like that. So you can't just go and sit in a call and invite Julia into a call and sit there and chat about how you think you're going to do it and then push up the code. You have to sit, you have to have a public conversation about what you intend to do. You have to get that documented as a spec that the community needs to all agree on together to make sure that the use cases of the entire community, that it works for everybody. The nice thing about this is we end up with better software because you have more folks saying what they think needs to be there, and you'll have better use cases because you'll have people that are come in and chime in on their use cases as well. So that actually helps more. So it's the community that controls the roadmap of the project and not any individual corporations or anything like that, which is important. Open development, I mean, that's a pretty straightforward one. All the code commits are done in public. Code review is done in public. Nothing behind any walls, nothing that you have to be invited to do. Maybe you might need to be a core member to be able to merge code, but anyone can, produce and push up code without any requirements other than some legal stuff. And then finally is open community. So going back to the open design, any discussions, anything that, public emails are all archived over, our mailing list archive. All the Openstack official IRC channels are all logged and publicly available. So there's not at any point any discussion that's happening that you can't be part of. And throughout these, 4 opens, something that's really nice that the projects usually do is the Open Infra Foundation helps host something that we call the PTG, or the Project Team Gathering. And so that's a unique, nice thing about the foundation, where it hosts all of these projects together. So back when we could travel to places, they would usually find a place, and the PTGs were very important, and they were very specific in that this is not a sales event. You're not going to be scanning any badges. There's nothing. There's no selling. There's none of that that's going to happen. And at the PTG, it's just the developers coming together, and there's rooms available, and developers of different projects sit in rooms and just collaborate, design, figure out what they're going to do for the upcoming cycle. So these are usually hosted every 6 months. So every cycle, you decide what you're going to do for the upcoming next release. And those are open for everyone to join. And now that it's, we're hosting them virtually, I feel like they're even more accessible. So they're free to join. And so, if you want to be part of OpenStack, the next PTG I think is happening in a week or 2, something like that. And you can just join and give your opinion and say, I think this is a good idea. I think we should maybe do this. And this is, I think, important to help with the 4 opens.
It's next week, actually. We can send the link out. But it's just in a few days. If you want to join the PTG, we can send that info around.
And one of the nice things about the PTG is you sometimes do get operators that join the room or join the discussions. So you get these cloud operators from these huge, giant companies that you don't see in the news. And sometimes you're able to get some of the details out of them. Like one of my favorite things is when operators come into these discussions and go, well, we ran into X, Y, and Z problems. We fixed it this way. We don't think it's the way to actually do it in the community. We'd like to see a fix upstream so that we don't have to carry that burden ourselves. And that's a very common discussion we see in these communities, because a lot of times they don't want the press, they don't want visibility, but they want to give that feedback somehow or help improve the software. And a lot of times also that they may have rules and requirements that don't allow them to directly push code, basically.
Mm-hmm. Okay. So next question is for you, Mark. Where does the money for the foundation come from?
Sure. Yeah. So I think we've talked about platinum members and how we might need to rename that to Dogecoin, but so we have over 60 companies around the world that fund the foundation. So those are basically silver, gold, platinum, and if you would like to join, you go to openinfra.dev/join. You can become a member too. It's free for individuals. You got to pay if you're a company. So that's basically where the money comes from. So those companies, everybody from the Red Hats of the world that obviously are massive in the open source world, and startups and everybody in between. VEXXHOST is a member as well, so they're an awesome contributor to what we do. So just companies and all over the world that really believe in our mission, which is again build communities that write software that runs in production. And if you look at just like the OpenStack example, that is currently about a $7 billion market around the world. So that gives companies a reason beyond just goodwill to want to invest in what we're doing and make sure the community is very effective and producing software that runs in production. And so I don't know if that answers your question, or if you have any.
So what does a Red Hat or a VEXXHOST get for the money they pay for their membership? Is it the ability to join those PTGs and be able to talk about their needs? What are the benefits?
Yeah, it's a good question. So they're all shaking their heads. So it's a very good question, because I think that it's somewhat counterintuitive, because we're very, very protective of the fact that the 4 opens mean that writing a check or not writing a check has no bearing on your ability to participate in the project. You don't have to write the foundation a check for anything to participate in the PTG, to contribute code. And so, these companies, I think first and foremost, just want to see a neutral home that helps organize these activities. It's not an exclusivity thing. It's actually an inclusivity thing. So it's a bit counterintuitive. Do you think of sort of the for-profit, mindset of like, oh, okay, they're paying, they must be getting something that's really exclusive. But really what they're doing is they're giving us the resources we need to create a facilitation of an organization of these types of events, to bring people together, to do the testing and infrastructure that we need. We have infrastructure engineers on staff that are dedicated to all this build, helping operate all this build infrastructure. So these 17,000 code commits that are being merged in a 6-month cycle, can be tested, and we can have quality code. So they're in it for the long game. When we went around and talked to companies and said, look, as we become the Open Infrastructure Foundation, here's our vision. We're looking at the next decade of open infrastructure. Like, what is the work ahead? We need to enable things like GPU support and have better enablement for ARM architectures and FPGAs, and like the needs of infrastructure. Although the kind of hype has moved up to higher levels in the stack, and what people talk about on Twitter every day, like as Julia said earlier, the warp engine is warp technology is not standing still. So that underlying infrastructure, a lot of work needs to go into it. And I think when these companies are looking at a $7 billion opportunity, or 20 billion when you look at the larger infrastructure landscape, they're saying, how can we move a little bit faster? And the way to do that is through collaboration. And the most efficient way to do that is open source. And to do open source well, a foundation can help facilitate that. So it's really about the long game, and companies seeing a much bigger opportunity. So that the amount of money that they're putting into the foundation, they get back manyfold, and just seeing the industry move forward more quickly, more efficiently, kind of getting this, staying up to this breakneck pace of infrastructure automation. So, and
do you have a sales team to sell that? Because it sounds like it's a hard value to convey to a company before they write you a presumably fairly large check.
Yeah, I mean, it's not your traditional sales cycle for sure. I think that, myself and Jonathan Bryce, who's our executive director, we're always talking to individuals at different companies. And, we have a team that's focused on marketing and working with all of our members. So, we have a nice group of people that are helping to organize everything we're doing. And we don't have I would say a salesperson. It's really, we think that our work in serving the community and making the industry move a little bit faster every day kind of sells itself, hopefully, and through the results we deliver versus kind of a traditional, VP of sales kind of person on staff, because we are a nonprofit. So, everything is a little bit counterintuitive, but
and there's no backdoor kill switch. You can't turn their service off or anything.
No, unfortunately not. No, we not only that, there's not even tracking in the software. So the funny thing about it is we know of these incredible users of OpenStack all over the world, but there are a bunch we don't know about because we just have, it's free software. If they want to run it and they don't want to tell us, I mean, I happen to know that most of the large banks in the world run OpenStack, but I can't tell you their names because they tell you in the hallway and they're like, we can't talk about this publicly. So, it's fine. We don't need to shout them all from the rooftops. But CERN, I'll give a shout out to CERN, the Large Hadron Collider. I wore this shirt just so I could say thank you to Tim Bell, who's also on our board. But yeah, CERN's a Large Hadron Collider. They have over 300,000 cores of compute. They analyze all that data coming off of the collider, which is trying to find the missing 95% of mass in the universe or something. I'm not a physics expert, but
we put it somewhere.
It's wild.
It's around here somewhere.
I'm like looking for it. It's probably in my office. You can't see the messy part of my office, but it's most likely over there. But they haven't found it yet. But they've got an awesome, huge cloud, and so we're doing a lot of good in the world. I like to think with the scientific progress, and then of course there's all kinds of commercial users. Verizon has millions of compute cores they manage with OpenStack. So long-winded answer, but hopefully that sheds some light on it.
Does any of your software run the storage array that they have? They've got at CERN, they've got this amazing room that, as far as you can see in basically every direction, it's this something like 5 terabyte tape drives. And they have random access search capabilities. A scientist who wants to know something from all that data can do a random access query, and then the query computes, and that turns into a set of robotic instructions where a robot will drive down the aisle, pull out a 5 terabyte tape drive, bring it back to the reader, load that memory into a storage facility, put it back in, go get the other one because it's random access, right? It can be anywhere in the entire room, and it could be multiple of them. And then some days later, they get the answer to their query after the robots have fetched all their tape drives. Julia?
So I was on a tour right before the pandemic, and we walked by one of these, or actually 2 of these giant tape arrays. And I don't remember if they said it was open source, but it's definitely a piece of software they've developed in-house to manage that tape array specifically. I think they probably have some sort of driver to help facilitate some other related aspects, but that's largely for their batch processing and how they get the data into their batch processing systems.
Mm-hmm. Fascinating and very cool to look at. That's like,
oh yeah,
right around the corner is the room where the 2 computers that Tim Berners-Lee launched the internet on are sitting there. It's a great place. And sorry, CERN tangent. You did this, Mark. You're driving.
I can't help it. I love it.
You drive through cornfields out into like the countryside of France and Switzerland, and it's like, I don't see anything around here. And then all of a sudden, the biggest power generation unit you've ever seen in your life is standing up in the middle of the cornfields. Like, we must be arriving at CERN. Big transformer.
You should have the CERN team on. Just do a dedicated episode. They're super.
Oh, that would be
amazing
really fun.
People. We can
idea.
Look that up for you.
All right. So, Mohammed, is as an individual contributor, is the part of the software that you work on the most Zool because it's the CI/CD part, or no?
Well, I think as a deployer, I always end up dabbling in many different projects because there's so while I've been involved a lot in deployment tools, as a deployer, you always have kind of issues, a little bug with the software here or there. And so me personally, I've been involved a lot with OpenStack and all the different OpenStack projects. So while you're not going to see me at the top of the list of every single of one specific project, I'll be on the list on many different projects. So, whether we're working on some bare metal stuff and contributing fixes there, whether we're working on some virtualization issues and some stuff there, and whether it's Zool as well, that's something that we're involved in as well. And I think that, honestly, Zool is probably one of the really, really interesting projects that I think probably has an impact on or could have a positive impact on any software development project. So, because I think a lot of the stuff that we talk about is very infrastructure, purpose, and a lot of people these days don't run their own infrastructure. That's just a reality that sometimes exists, right? But I think Zuul is one of those interesting projects where you could use it still, even if you use infrastructure anywhere. So what's really interesting is with Zuul, it runs jobs. So every time it starts to get you make a change, right? You push up a change or a pull request. And the nice thing is Zuul started with supporting Gerrit only and running jobs inside OpenStack. That was the only thing that it did because that's what we used it for. And as Zuul grown, now it can run jobs on AWS or Google Cloud or against OpenShift or Kubernetes clusters. And it can receive jobs from a pull request on GitHub or GitLab or Gerrit. So, with more individuals and, involved, we ended up with more features. But the really nice thing is, if you push up a change, Zuul will actually check out the current state of the main branch and put your change on top of it, and then test it with the change on top of it already. So you're always getting an idea of what your change is going to look like once it's merged, which prevents that whole thing where if I make a contribution that touches component A and changes the API, and I'm based off a specific point off the main branch, and Julia happens to be working on that same thing as well, but she changes another aspect that touches it. When my stuff merges, Julia's change is just going to break. And if you merge it, it'll just be broken because it was never tested against the actual final state of the branch. And so that all happens on its own, as well as cross-dependency tooling. So let's say you have a library and you have your application and you want to make a change in your library, but you want to test that change actually worked in your application. You can actually, in your commit message, just say depends on this other change. And then Zuul will automatically check out that specific version of the library, including that change, and test your application against it. So you can actually check it before even releasing a version of your library or merging code that you end up having to revert or something.
Is that code that would mainly be at the application layer, so web applications or things running on the infrastructure, or are we talking about the infrastructure code itself?
It doesn't really matter. And that's the beautiful thing about this. In the project I work on specifically, we have unit tests. We have some functional tests, and then we have a slew of integration tests and full integration jobs. So essentially, what we're doing is we're exercising every level that we possibly can, and they're also all different jobs that have been defined in Zuul. So we have a job that ends up running unit tests of various flavors. We have some functional testing that runs. Then we also have this entire batch of scenarios that are different configurations with different needs. And it's kind of why we end up getting a lot of operators tending to contribute back tiny fixes, is because sometimes when you twist a certain knob a little bit of a different way, you get different results. Or you need a specific configuration in your environment to meet your operating needs.
Okay. So can I jump in here after you're done?
Sure. Yeah. I was going to say that's the true power of open source, is that collaboration and that end result. But you have to define all these jobs, and they can look like anything.
Okay, that makes sense to me. Mark?
Yeah, I just think, it kind of to both their points, Zuul is applicable to anyone who's writing software, which sounds super broad, but to give a concrete example, Volvo, for example, they're writing software that runs in their cars for self-driving, autonomous driving. So they're using Zuul in the process of developing, testing, and shipping code that ends up in an automobile on the road. And we all know Volvo takes reliability very, very seriously. So, when you think about how much more reliant we all are in our day-to-day lives on software, and we know software is not always great, right? Software breaks all the time. So anything we can do as a community to ship something like Zuul, get more people using it, improve the quality of that software. I mean, the applicability, it affects more and more lives. And it's just such a powerful tool that, to Mohammed's point, kind of transcends, is it infrastructure or not? It's actually not, it's not really limited to infrastructure as a service or cloud. It's really, if you're writing software and you have a lot of people contributing to it, you want the code quality to be good, but you also want to go really fast. that's what Zool is. And that's why they say, stop merging broken code. And, Volvo wants you to merge into the left lane, and everybody's trying to merge. So we want to do those merges safely, but also faster. And so that's just one example. Like that code might end up running anywhere, but in the development process, before you put it into production, or as you're trying to create new versions, so you can maybe send an update over the air down to the cars out on the road, that pipeline of innovation that's coming out of software, really anywhere you think of that in play across our economy all over the world, they can benefit from Zool. So it has a big impact, and it's really just getting started. A lot of people don't know about Zool. So we're kind of upping our efforts to educate people and invite them in to try it, because it's very powerful.
Yeah.
Thank you.
A little note on that. So how usually most projects will have like a Travis CI badge or some form of CI badge that's going to say like build passing or build failed or whatever. So if you go to the docs page, recently there was a change to allow for some periodic pipelines, so let's just ignore that. But if you go to the badges page on Zool, because Zool controls the merging of the code, and so you don't actually merge branches. You tell Zool to merge, and then it does the test, and then it merges once it passes all tests. It's just a static file. Like there's no dynamic thing behind it. It's just a static file that says Zool gated, because you don't need to have it dynamically checking the API if the most recent job had passed or not, because your primary branch is never broken because no broken code had ever merged. And so it's kind of like an interesting thing to kind of think about, that, our badges are just like a kind of almost as a joke, like, yeah, I'll just say something that says passing all the time and it'll look like my jobs are always passing, but that's the reality when you're using Zool.
So there is another reality. And if you have things that you don't directly control, yes, you can eventually be broken.
Yeah. I was thinking like ignoring the bit rots and things like that. For the most part, it's cool.
Upstream libraries that are not maintained by the community, occasionally we do see some breakages, and that's where things break. But we also identify the known versions, and we track those versions too. So that's one of the things that Zool helps us a lot, where we can check those requirements, make sure that, oh, this looks good. Okay, we know the good version. Oh, we tried to update the version and it broke. Yeah. Well, there's a problem there. We need to fix it. So what ends up happening is with such large communities is we end up contributing fixes into libraries, all sorts of things, and other projects, because we identify the failure fairly early.
That sounds actually really interesting and useful potentially to the Platform.sh case as well. So we don't talk so much about our product and company on the show, but what it does is it takes a Git repository that's both the application code and the definition of its infrastructure, and kind of builds that. And then therefore, when you create a branch of that, it builds that too. And it's kind of a common concept these days, with the added detail that it does a copy on write copy of all of your persistent data into that new environment. So you're always testing on a perfect copy of your production code and data, sanitized if you need it to be. But the merging of the workflow that we always conceive of is like every developer will go out and like create a PR for their change, and that creates a new branch, a new environment for testing. You test on that and you do all the testing, and then a human goes and merges it. So human goes and merges it. But it sounds to me like Zool actually gives you the tooling where the programmers could create their PRs, and that would basically, if they had the test framework in place that they trusted enough to, like, there's always the stakeholder at the end, right? Like you can't.
Yeah, there is still a manual approval. So usually with the difference is, rather than a human merging the code, it's a human approves of this code, and then Zool does the merging and everything afterwards.
Okay. That's cool. That makes sense.
I think it's one of the things where we see many cases where human may say it's good to merge, but the CI system may go no, and that just means we have to revisit it, or there's a transient failure when we're running the job, which those things do happen. Especially at our scale. That's the curse of scale, of giant, huge CI scale.
Yeah.
Everything breaks at scale, and so we've broken everything that can be broken. Well, maybe not. I shouldn't curse it that way, but we've run into plenty of those things.
It's Friday, Mark. Let's not.
It's Deploy Friday. That's what they call it.
Say that on a Monday, maybe.
It's Deploy Friday. We're supposed to
No,
talk
Mohammed,
about,
it's Deploy Friday. Mark's got the right
I'm on
idea.
theme.
Here.
No, I just want to say,
You use the right software, you can deploy on Friday.
That's right. I just want to say, like, all this software development we're talking about, all these tools, all this pipeline, it's absolutely driving more demand for the underlying infrastructure. Like we do care about infrastructure, and that's, the open source, OpenStack pieces and Airship and Starlingx and Kata and these other projects. Like, more infrastructure is being used than ever, and I don't see any sign that that's going to slow down. So this incredible explosion in infrastructure needs, and 5G is going to change the game in terms of edge and bottlenecks and all that kind of stuff, and latency. It just continues to go up and away. So we have sort of two big trends here. We have more open source than ever, which is great, but also very complex, right? It's hard to make it all work together when all the pieces are moving around and releasing new versions all the time. And then more infrastructure than ever. So when you look at these trends together, I mean, that's kind of where the work of our community and foundation is focused, is trying to wrestle with that, because these are very positive trends for humanity. More open source is good, more automated infrastructure is good. But it also, it's like more infrastructure, more problems, I guess I would say. And so we're trying to tackle those, and it's a fun space, because it's far from solved, because we're just growing at insane rates as human beings, like consuming infrastructure. All this software needs infrastructure, so that's what makes it fun to be at the layer of the warp drive engineering team.
Well, so let's talk about Starlingx IO for a second, if we can. That caught my attention because it's used for managing infrastructure at the edge. Who can define that for me? Paint some pictures for me about what that is.
So the edge is one of the things I learned very early on in discussions with operators and telecom specifically, is it's impossible to define the edge in common terms. So we ended up with an edge working group, which is still in existence, and it's really what individual contributors view as the edge. And in many cases, it's like your radio access networks or your content distribution cabinets that are designed to cache your movies for the neighborhood to watch. Those sorts of things.
Your neighborhood has one of those?
It might. I don't know.
I wish my neighborhood had a box with all the movies cached in it.
There
it used to be Blockbuster, but now it's gone, right?
There's some weird boxes on the end of the street, so you never know.
So you think those are like caching all my Netflix? That'd be so cool.
Again, you never know. If you think about how content distribution networks work, it all started with putting servers in data centers, and now it's getting closer to putting servers as close as possible to users so that you have minimal latency. And that's also important for like 5G and self-driving cars, because they need that extra piece of data. Oh, wait, there's a problem ahead. I should do something different than my current path.
So the Volvo the edge?
It could be the edge. It could be the radio access network your cell phone talks to. It could be the cabinet on the end of your street. In theory, it could be servers in your own home if you have them.
So what does the software help me do with that then?
The software specifically helps you manage that infrastructure, helps you abstract away the lower level layers so you don't have to really think about them, and makes it easier for you to manage them. The system.
So if a lot of those tasks you might have done manually before. So we're taking the software approach is replacing things that might have been done manually. So if you've got this infrastructure in every Starbucks in the world, or in every radio access network, and near every tower, or anywhere that's highly distributed, it's very, very costly in terms of time and people to like manually manage that stuff. So this is why edge computing is actually even more important to be super repeatable and reliable, and that a software approach is absolutely necessary, and then good software is necessary. Sorry to interrupt. I think that's like part of why it's key.
That's absolutely key, and it's hard to put into words because people don't agree with the edges. it's one of those, we agree, we can't agree.
So, but I'm so foggy on what Starlingx.io actually does.
Yeah, so I can talk a little bit about, if that's okay.
Yeah.
Starlingx. So for Starlingx, the need for it came out because, traditionally data centers were like, people had infrastructure in very big data centers and they had hundreds of servers, and it was like one giant deployment that ran everything, and you had to manage one giant deployment. But as as people start to manage infrastructure more with automation, they started doing things like, for example, let's say, I am a Starbucks and I want to manage the POS systems across all the Starbucks branches around the world. And I want to be able to have my software team develop and use CI/CD pipelines and, interact with all these systems using APIs and stuff like that. So previously, that was something that was very hard because obviously, you don't have entire clouds and API-driven access to these small nodes usually. We're not talking about, you don't have 100 nodes inside of a Starbucks. You might have a small server that doesn't even barely have any cooling or anything like that. And so the idea with this, with something like Starlingx, is that it allows you to have these very small miniature deployments and as much as you can of them, but they're orchestrated in a way where you can easily deploy them and you can easily manage them at scale. Because managing one big cloud is an interesting problem of scale because you have a lot of systems, but managing 100 clouds is another 100 one-node clouds or 100-node cloud are two huge different problems to figure out, because you have things like lifecycle. How do you update them? How do you keep them up to date? And there's other things like resilience. I know, if I maybe quote me or not, I might be wrong, but I think Starlingx has been used even like in like planes or stuff like that. And those are like places where like you need it to be ultra reliable. You need it to be able to self-recover. You need it to be able to lose all communication, but still be able to operate on its own, even if it's completely disconnected. So the idea of Starlingx and the edge is, I think maybe we might not agree where the edge is, but the idea of building a cloud that is not necessarily inside of your data center, but it's kind of its little island and could fully lose connectivity, could be completely unreliable. But how do you minimize the unreliability or maximize the reliability of it?
Awesome, thanks. And so the example that I came to mind was if I were a smart TV manufacturer, internet connected TV, and I wanted to manage the software updates on that TV. Is that the software I would turn to, Starlingx? If you're looking to run VMs on your TVs.
Yeah, I mean, possibly, but I think that the more common use case is where there's a need for more processing power than you would have just like in a TV. So that it's not quite going to that level of the edge, but if you're having content delivery, if you have a content delivery network because you're Hulu or somebody like that, and you need to make sure that that's one step away from the television at a nearby point of presence somewhere, that maybe that's the use case. But I would say like, really, another way to think about this, Mohammed described this really well, which is like it's cloud-like technologies in a place that don't look anything like a data center. So they want those. They need lots of compute, storage, and networking, and they need it close to where the customers are, where the customer experience is. But it's not a data center, right? So you need a different sort of mindset when you're running 100 or 1,000 little mini clouds or micro clouds. A lot of the technologies get reused. You can use Openstack, and Starlingx does use Openstack. And Starlingx, I think you can think of as this tightly integrated solution that allows you to provision like virtual machines and networks and storage that you would think of traditionally with an Openstack kind of thing. And it uses that. It uses Kubernetes to kind of bring in the container orchestration pieces. But it's more tightly integrated for that really small environment where you don't want to send somebody out there to kind of log in and try to administer it, right? You want to be able to do it remotely, replicate it thousands of times, and manufacturing is another good example. So if you have like this giant manufacturing facility, a roboticized manufacturing facility, you have sensors all over the place, and you want to orchestrate all that, you need compute, storage, and networking at the edge. That's basically cloud, right? And so it doesn't look like a data center. It's inside of a manufacturing facility at like an auto manufacturer, Toyota or somebody like that. And you imagine these sort of next generation next generation manufacturing facilities that are highly, highly automated, So that puts demands on like collecting all the sensor data, storing it somewhere, analyzing it. So they may have custom applications that sit on top, but the need to have that data center-like, cloud-like power, but have it inside the manufacturing facility, that's where Starlingx really shines. And so it's a different sort of way of delivering the same types of benefits that people have learned about through cloud. It's just taking it out of the data center and putting it closer to the application.
And it says newly open sourced. Who open sourced it?
Yeah, so a couple of the companies that originally were big contributors to it was Intel and Wind River. So Wind River is known for kind of their industrial solutions that, I think they even have some software that's running on the mission to Mars. It's active right now with the Mars rover. So, they're used to building very, very reliable, long-term embedded type systems that absolutely cannot fail, right? And so historically, that sort of stuff maybe wasn't always built in the open, but it's just another industry, another delivery model that's embracing open source. And so you saw that with Wind River. They embraced OpenStack, they embraced Kubernetes. They came together and said, let's build something purpose-built for the edge, using those kind of components, but even more tightly integrated than what you would just get sort of downloading the source code of OpenStack or Kubernetes and kind of rolling your own. And so they also have a commercial product based on Starlingx, but it is open source. It's an open community. So that's probably the biggest company initially that's kind of put tons and tons of resources into making Starlingx a success. And since then, we have a lot more contributors from around the world. But that Wind River, I would say, if you want to, sort of think of the company that really kicked it off, that's the best example.
Great, thank you. So we are coming up to the top of the hour, but I have one more question that actually slipped my mind when we were talking about the 4 freedoms. Your logo is comprised of 4 bent lines. Is that a tip of the hat to the 4 freedoms themselves?
It is. I'm glad you asked. I don't know if we've actually gotten that question before, but James, who's a designer that works at the foundation, and Wes, they will be super excited to hear that you picked up on that, because that was actually part of their. I don't even know if Julie and Mohammed know this, but that is actually that was actually, maybe it's an Easter egg, but it's just great. They're going to be so excited that you picked up on that. It is in fact modeled after the 4 opens. So that's exciting. They're going to be happy you asked that. So
I liked
to them.
I liked it that you put your philosophy and your philosophy front and center in your messaging on the website, and that you present yourself as if everything about your organization flows from those principles, even the logo. And the things that I heard about the PTGs and everything and the governance models actually corroborates that messaging as well, that everything does flow from those 4 opens. So I thought that was worth mentioning and very cool. So
thank you.
Awesome. So Julia, Mark, Mohammed, thanks so much for this conversation. It was really lovely. I'm a fan. And we're going to do more OpenStack presentations on Deploy Fridays in the future. So maybe we'll see each other here again.
Sounds good. Thank you.
Thanks for having us.
All right. Thank you.
Thank you.
Bye-bye.
Bye-bye.